Namaste student. Today we're going to see algebra of limit. Under this two theorem we're going to see. First one, that is if two function fx and gx exist such that its limit fx and gx also exist. Limit of fx as x tends to a and limit of gx as x tends to a exists, then we'll see that this 5 property follows. Okay, and second one we're going to see that is for any positive integer n, that means n should be 1 2 3 any natural number, then this statement also exists, that is limit of x to the power n minus a to the power n by x minus a as x tends to a equals to n into a to the power n minus 1. Okay, so these theorems we're going to see using the example, and this one we're going to prove logically. Let's see one by one. Here the first one says that limit of sum of two function is the sum of the limit of the function. That is, for example, if I'll take here function fx 2x and the gx as x square, and if I'll add these two first and then if I'll apply the limit, I'll get whatever the value I'll get the same value if I'll take separately. See here, this one you can see directly I have used direct and separate way I got the same value. Similarly for difference also, difference limit of the difference of two function is the difference of limits of the function, like using this one. Okay, I hope that you can do by yourself using the same concept as I have applied for the addition. For subtraction you can apply by yourself. Next one, if you go for the multiplication, that is limit of the product of two functions is the product of the limits of the function. I've taken the same problem. Now first I'll multiply, I'll get 3x cube. Now I'll apply the limit here by substitution method. 3 here substituting here, that is I am getting here 81. Similarly now I'll take separately means limit on function fx and the limit on function gx. Separately I have substitute the value, and at the end I am getting the same result as for the first one. So a similar concept we can apply on division also, but here we have to look at the denominator. If denominator is not equal to 0, then only we can apply this property. And here one more, that is the fifth one, but it is a special case. It is a special case of the product rule. You can say this is the quotient rule, product rule. So what you can see that if gx become lambda, that means any constant number if I'll take here, then this constant number will be outside and limit will be on function of fx. Okay, now we're going to see the theorem. Let's see the theorem. What the theorem says, for any natural number, that is limit x tends to a, if we'll take x to the power n, a to the power n by x minus a, I'll get here that is n into a to the power n minus 1. This one I'll get. So let's see. So for that, what we're going to do, let transpose this number, like if I'll substitute x minus a as h, so what I'll get as x tends to 0, we'll take it 0, sorry, not a, a only. As x tends to a, what you can find here, if you substitute the value of a here, you will get here a minus a 0. That means this implies as x tends to a, we get here, what we get, h tends to 0, and x become what, a plus h. You take this a this side, now you substitute this value in this part. So limit x tends to h, we have here a plus h to the power n minus a to the power n by h. Okay, so what you can find here, you can see that a plus h to the power n will going to apply here. See, if we use direct method, substituting method, you may here apply also substituting method. Like if we substitute here a to the power n minus a to the power n give us 0, and a minus a give us 0. 0 by 0 is indeterminate form. Direct substitution method you can apply here, can't apply here. Similarly, if after transforming this limit into this form, this function into this form, and then you are substituting, again you are getting 0 by 0 form. So direct substitution method you cannot apply. So what we're going to do, you break this one using binomial theorem. I hope you remember binomial theorem. Here we have, let's recapitulate a little bit binomial theorem. So we'll apply here binomial theorem. Once we apply the binomial theorem, what we'll get, so it will remain as, so that is a to the power n plus n a to the power n minus 1 into h plus nc2 a to the power n minus 2 into h square. Similarly, we get here a nc n minus n minus n n minus 1. You can see that is a to the power a to the power n minus, that is we'll get a only, into h to the power n minus 1, and the last one we have, that is h to the power n, and divided by, and that is totally in bracket, minus a to the power n divided by h. Now you can see that a to the power n and a minus a to the power n cancel each other, and if we take common h, you can see that h in each term, you can see that h is common. So we'll take h common. What we're going to get, take h common, we'll have here, that is n a to the power n minus 1 plus nc2 a to the power n minus 2 into h plus nc n minus 1 a into h n minus 2 plus h n minus 1. Now, and the denominator is h and h cancel each other. Now if we substitute the value h, what you can find, except this term, rest term become what, 0. If we substitute value 0 into this, you'll get 0 into this, 0 into this, you'll get 0 only. We'll get here n into a to the power n minus 1. This is our proof. Now we'll see the little application on this one, means some problem we're going to use using this one. What you can find, like if I'll give you one problem. Okay, next page we'll see. So here, if we take the problem like limit x tends to 2, okay, x to the power 4 minus 2 to the power 4 by x minus 2, then directly you can see that this follow this method, limit x tends to a, x to the power n minus a to the power n by x minus a. Direct we can write what, see, this as x tends to a, and here we have a and the power same. So what we can write, the power will remain as n and a to the power n minus 1. That means here it follow the same rule. So n is here 4, so 4 into a is your 2 on the power n minus 1, that is 4 minus 1, that is 4 into 2 to the power is what, sir? That is 3, that is 4 into 8, we get here 32. That is our answer. Another question you may try by yourself. Here I have one question for you. Limit x tends to 2, x to the power, not 2, 3, take x to the power 7 minus 3 to the power 7 divided by x minus 3. So I hope that you can solve by yourself. So now we have two more property, that is limit of polynomial function and limit of rational function. Let's understand the meaning of this one. What it says that if you have polynomial function, I hope that you remember the polynomial function. The polynomial function look like this: f of x such that a to the power n x to the power n, not a to the power n, a n x to the power n, a n minus 1 x to the power n minus 1 plus a n minus 2x to the power n minus 2, and so on. That is a xn plus a naught. So what about the an minus 1, an minus 2, a naught? These all are belongs to real number, and remember an should not be 0. And where n minus 1, n minus 2, these all are what, sir? These all are whole number. These all are whole number, belongs to whole number. Then this type of function we call polynomial function. And if it is a polynomial, fx is a polynomial function, then one property of limit exists, that is limit of x tends to a function f of x can be written as f of a. That means limit of function fx as x tends to a equals to functional value of the function at x equals to a. So this is your what we call limit function. For example, if not for example, if we'll take here, so if I'll take this function like this, what function can be written as directly if I substitute the value here, that is what an, and I'll write here x to the power n plus an minus 1 x to the power n minus 1, and continue if we'll go like this. So what you can find that if you substitute the value a here, that is an into a to the power n plus an minus 1 a to the power n minus 1, and here a into a plus a naught. This is nothing but a functional value. So, and then for rational function, what is the definition of rational function? The function should be looked at fx by gx, where fx and gx are polynomial function, and the gx should not be equals to 0. This is a rational function. And if it is a rational function, and if we apply the limit on it, then this gives us what? Direct value f of a by g of a. That is a property of limit. I hope it is clear to all of you. Thank you.